Hello everyone, today I am going to present my Physics 101 project, which is comparing spring constants and parallel springs using Hooke's law and spring oscillation systems. This experiment has objective, which is intuition of the students to grasp the lemma of spring behavior on parallel and series bonded springs. Students can analyze the spring constant behavior by applying Hooke's law and spring oscillation period formula. With the data, they can plot the graphs to find the theoretical value of the spring constant on the graph. We have two theoretical background for this experiment. Springs which have parallel bondage, which like I shown in this picture before, have a summation of their constants, and springs which have series bonded, like in this from I showed before, have a negative effect of total constant value. And Hooke's law speaks about the displacement of the spring when a force is applied, and with the force applied, the multiplication of the displacement value and constant spring constant is equal to force that is applied. And period of spring oscillation is all about this formula, like I showed in this before. It's like 2p multiplied by square root of mass divided by spring constant value. And as in the experiment footage that like in this before, we can show our experiment. I can show the part B of this experiment by spring oscillation parts. First, you can see the normal spring behavior on oscillation period, and second, you can show the parallel spring behavior, like with less periodical time. At final, you can see the series bonded spring behavior in more periodic time. With that graph, you can show the average spring displacement behavior on the periodical graph of the spring behavior, and you can show the oscillation period graph with like that than before. And at conclusion, we can extend and reduce the normal error values of this experiment by using more professional experimental tools, like maybe laser measurement for displacement, or micrometer for displacement calculation, and laboratory stopwatch rather than stopwatch application. And we can control the experimental area by reducing the air resistance to reduce the random probabilistic, and we can extend this experiment by redoing multiple times to have a median value for our experiment. Thank you for listening to me.